Consider a scenario in which a warehouse worker in California sustains a back injury on a Monday morning. By Tuesday, the employer files a first report of injury. The insurance carrier is presented with a collection of documents, a handwritten incident description, an emergency room discharge summary containing ICD-10 codes, 2 witness statements, and a supervisor's account. Someone must extract structured data from these documents, assess compensability, calculate the worker's average weekly wage, apply California's TTD benefit formula, authorize medical treatment, and document each step with the sufficient details to withstand a workers' compensation appeals board review years later. This is what we are going to make tangible today. Hello everyone, I am Niraj Shah, an engineering leader in insurance technology. Over the next 20 weeks, I will design, build, and publicly release an agentic AI workflow framework for regulated industries. It is called VenturiFlowAI. This is week 1. Let me show you what an adjuster actually deals with. I've created a synthetic workers' compensation claim, entirely fictional but realistic in every detail. So this is the claim process flowchart for the state of California, which shows a high-level workflow. It describes what the employer and insurance company are responsible for and the timeline that employees can expect a response from them. The employer is responsible for providing the claim form and for sending the completed form to the insurance company within 1 day. An insurance company is obligated to respond within 14 days. This is the first report of injury, the FROI. The employer filled this out. The incident description is handwritten, partially ineligible, and uses internal abbreviations. An adjuster must extract from this the date of injury, time, location, mechanism of injury, body part affected, and the employer's account of what occurred. This is the emergency room discharge summary. ICD-10 codes, International Classification of Disease codes, a diagnosis, a treatment provided, medication, follow-up instructions. The adjuster must cross-reference these codes against the policy terms. Does this diagnosis fall within covered conditions? And this is the employee's own statement, handwritten, describing the injury in their own words. The adjuster must assess whether this account is consistent with the employer's version and the medical evidence. That consistency assessment is a judgment call. It is not a formula. What makes workers' compensation particularly demanding is the state-by-state regulatory variations. Every state maintains its own statutes, benefit formulas, fee schedules, treatment guidelines, and dispute procedures. California employs its own classification system through the WCRIB, not the NCCI codes used in 35 other states. It has a unique permanent disability rating methodology, its own medical treatment utilization schedule, benefit caps that change annually. New York mandates its own medical treatment guidelines and requires electronic filing with the Workers' Compensation Board. Different benefit structure, different forms, different deadlines. Texas is the only state where private employers are not required to carry workers' compensation coverage at all. This creates a parallel non-subscriber system that does not exist anywhere else in the country. Florida uses NCCI codes but applies PPD, permanent partial disability, scaling formula that differs from nearly every other state. A carrier operating across these 4 states is not running one workflow with minor configuration differences. It is running 4 materially distinct workflows, different formulas, different deadlines, different forms, different regulatory bodies. Four factors that undermine standard AI in regulated industries. Why does standard AI tooling fail here? Because regulated verticals share 4 characteristics that most AI frameworks were not designed to address. First characteristic is auditability. Every decision must be traceable not only in the present but years into the future. State workers' compensation boards may request decision trails long after a claim has closed. A system that cannot explain its determination not merely unhelpful, it constitutes a compliance violation. Determinism: two workers with identical injuries and wages filing in the same state must receive identical benefit amounts. AI models are inherently probabilistic. The same input can yield different output across runs. That variability may be acceptable for a chatbot, it's unacceptable for a benefit calculation governed by statute. Third characteristic is data sensitivity. These workflows involve medical records, wage data, and employment histories, each subject to distinct regulatory requirements. Not all data can be transmitted to a cloud-hosted model. Some must remain on-premises. The framework must make intelligent routing decisions, not direct all data to a single location. Last characteristic is a workflow duration. Workers' compensation claim is not a single transaction. It unfolds over days or weeks and sometimes even months. Through intake, compensability investigation, benefit calculation, independent medical examination, maximum medical improvement determination, and potentially dispute resolution. Standard AI frameworks treat each interaction as a stateless. This workflow requires a durable state that persists across events separated by weeks. This gap cannot be breached by improved prompts. It represents a structural mismatch between the design of general-purpose AI frameworks and the actual requirements of the regulated industries. On the left, what standard AI gives you: a single model for every task, stateless sessions, compliance as an afterthought, all data routed to the cloud. On the right, what regulated verticals actually requires: multi-model routing, the right model for the right task, durable state management, workflow state that survives across days, weeks, and months, compliance as architecture, every action logged by default, not by configuration, intelligent data routing, sensitive data stays where it belongs. Workers' compensation is the primary example in this series, but the pattern is not unique to it. Healthcare prior authorization represents the same structural challenges. CMS 0057 mandates specific turnaround times, state prior authorization reform laws add further variations, and payer must document every denial with clinical rationale that survive appeal. Different domain, same architectural problem. This is the motivation behind building VenturiFlowAI, an agentic AI workflow framework, what the industry is now calling an agent harness, developed specifically for regulated verticals. Industry agnostic at its core, workers' compensation as the primary reference implementation, with healthcare prior authorization as the second vertical to pressure test the design. This initiative is not a theoretical exercise. Over the next 20 weeks, I will design the architecture, build the framework, evaluate it against real workers' compensation workflow, and publicly release a functional product. Every decision made transparently, every result reported honestly, including where the hypothesis proved incorrect. The LinkedIn articles go deep on the reasoning. This video makes it tangible, showing what the problem looks like, what the solution looks like, and eventually what the working system looks like. This is week 1. The problem is established, the structural gap is clear. Next week, I present 3 hypotheses that inform every design decision in VenturiFlowAI. Why autonomous agents should earn operational trust through shadow evaluation against human decisions. Why workflows should be composed at a runtime from operating procedures rather than hard-coded logic, and where the definitive boundary lies between the tasks suitable for autonomous agents and those that must remain deterministic. If you are working in insurance, financial services, or healthcare and attempting to move AI initiative from proof of concept into production, this series is for you. Subscribe and I will see you next week. Thank you.